Hey guys, it's Mrs. Applegarth, and we are doing some geometry today. We're doing Chapter 9, Section 1, also known as translations. We're going to start out with some definitions so that we are all talking the same language. And geometry loves a good vocab less, so here we go. A transformation is a mapping that results in a change in the position, shape, or size of the figure. So it changes position, shape, or size of the figure is called a transformation. Rigid motion. It's like when I do the robot. A transformation that preserves distance and angle measures. So you just take it and move it around. The sizes of the sides and the angle measures of the shape don't change. That's a rigid motion. An image is what we get after we transform something, a result of a transformation. A pre-image is a transformation that maps all points of a figure the same distance and the same direction. Okay, sorry, I had my definitions in the wrong order. So the pre-image is not a transformation that maps all points of a figure. A pre-image is the original figure. So it's what we started with, and the image is what we get after we transform it. A translation is a transformation that maps all points of a figure the same distance in the same direction. So it just shuffles it on over. The same distance in the same direction. Okay, let's see this in action. Example 1, we are going to complete the statement. If 4, 3 maps onto 7, 9, then 12, 10 maps onto what? Okay, so we are going to go the same distance in the same direction. So if we look, I know it might be a while for some of you guys, maybe you haven't done your coordinate fussing in a while. So if we start with 4, 3 on the x and the y, and we end up at 7, 9, what did we have, how far did we have to travel on the x-axis to go from 4 to 7? So on the x-axis we had to go plus 3. On the y-axis, how far did we have to go down to go, or up to get from 3 to 9 on the y-axis? Oh, we have to go 6. So if we're going to use the same mapping, we're going to now have the point 12, 10. We're going to move 12 3 places to the right and 6 places up. So we go 12 plus 3 is 15, 10 plus 6 is 16. So then this guy ends up at 15, 16. Translations can be written as big T with how far along the x we go, comma, how far along the y we go, and the little arrowheads there. This means we move right 2 and down 3. If it's negative, it's down, or if it's negative on the x, it's left. So we are going to describe this translation. So this is our pre-image using translation notation. So translation notation starts out with big T. It has the little arrowhead here. And then we are going to use 1 point on our figure so we can count how far we traveled to get to the second point. So how far to the right do we move? 1, 2, 3, 4, 5, 6, 7, 8 to the right. And then how far up do we move? 1, 2, 3. 3 up. And remember, rigid is that we are preserves the distance and the angle. So then we go, is it any bigger? Are the angles any bigger or smaller? And we say yes. It looks rigid. Woohoo! Okay, not too shabby. Example 3, given the notation, translation, -2, 4, what's the image of 4, 8? So remember, we're going to go left 2 places and up 4. So our new image would be at 2, 12. What's the pre-image of -2, 3? So we are going to go backwards. So here we went left 2. So for here we're going to go right 2. And we went up 4, so we're going to go down 4. This is a plus. Okay, so the pre-image is -2 plus 2 is 0, and 3 minus 4 is -1. So the image is just doing it straight and standard, adding or subtracting depending upon if it's positive or negative, and adding or subtracting the y. All right, let's have example 4. This will be fun. Triangle ABC has vertices of 3, 2. B is -1, 4. Sorry, I'm going off my pad. C is -3, 7. Okay, I am going to make a straight line out of this because heaven forbid I draw. Me trying to draw these lines would be disastrous. So we have this little triangle, ABC. Oh, he's a skinny guy. So really obtuse here. What are the vertices of translation of -2, -5 of triangle PQR? Graph its image. So we're going to take each of these coordinates. We are going to -2 from the x and and go down 5. Or go left 2 and down 5. So left 2, down 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. And 1, 2, 1, 2, 3, 4, 5. So we just translated this little guy all the way down here. And I believe, let's label it. Let's label it for fun. P, Q, R. Okay, so remember the translation, this is what you do to the x coordinate, and this is what you do to the y coordinate. All right, example 5. What is the rule that describes the translation that matches P, Q, R, S onto P prime, Q prime, R prime, S prime? So just to let you know, the little burp is, we call that a prime. just for funs. So let's use P to figure out how we went from here to here. So we went 1, 2, 3, 4, 5, 6, 7, 8. So we translated P to the right 8, and 1, 2, and down 2. There we go, Spaghetti-O. Easy peasy. And it's going to be the same for no matter which letter you pick, because if it's a translation, it preserves all the coordinates. All right, and let's see if I get all of the examples. Yep, that's all the examples. That is it for this lesson today. Thank you guys for joining me. Here are the answers to the homework questions. Let me know if you want to see any of these in class. Pause, fast forward, rewind, whatever you need to do, write the answers down. Number 17, 19. Oh, and do 21. Okay, here it is. 21, 26, and 42 through 44. Okay, you guys, go have an amazing day. We'll see you next time.